Diffusion of innovations is a theory that seeks to explain how, why, and at what rate new ideas and technology spread through cultures. Everett Rogers, a professor of communication studies, popularized the theory in his book Diffusion of Innovations. The book was first published in 1962, and is now in its fifth edition. Rodgers argues that diffusion is the process by which an innovation is communicated through certain channels over time among the participants in a social system. The origins of the diffusion of innovations theory are varied and span multiple disciplines. Rodgers proposes that four main elements influence the spread of a new idea: the innovation itself, communication channels, time, and a social system. This process relies heavily on human capital. The innovation must be widely adopted in order to self-sustain. Within the rate of adoption, there is a point at which an innovation reaches critical mass. The categories of adopters are: innovators, early adopters, early majority, late majority, and laggards. Diffusion manifests itself in different ways in various cultures and fields and is highly subject to the type of adopters and innovation decision process. History: the concept of diffusion was first studied by the French sociologist Gabriel Tarde in late 19th century and by German and Austrian anthropologists such as Friedrich Ratzel and Leo Frobenius. Its basic epidemiological or internal influence form was formulated by H. L. Pemberton, who provided examples of institutional diffusion such as postage stamps and standardized school ethics codes. In 1962, Everett Rogers, a professor of rural sociology, published his seminal work, Diffusion of Innovations. Rodgers synthesized research from over 508 diffusion studies and produced a theory of the adoption of innovations among individuals and organizations. The origins of the theory cross multiple disciplines. Rodgers identifies six main traditions that impacted diffusion research: anthropology, early sociology, rural sociology, education, industrial sociology and medical sociology. The diffusion of innovation theory has been largely influenced by the work of rural sociologists. In 1971, Rodgers published a follow-up work, Communication of Innovations. A cross-cultural approach, building on his original theory on the diffusion process by evaluating social systems. Elements: the key elements in diffusion research are: decisions. Two factors determine what type a particular decision is: whether the decision is made freely and implemented voluntarily, who makes the decision. Based on these considerations, three types of innovation decisions have been identified. Process: diffusion occurs through a 5-step decision-making process. It occurs through a series of communication channels over a period of time among the members of a similar social system. Ryan and Gross first identified adoption as a process in 1943. Rodgers' 5 stages, awareness, interest, evaluation, trial, and adoption, are integral to this theory. An individual might reject an innovation at any time during or after the adoption process. Abrahamson examined this process critically by posing questions such as: how do technically inefficient innovations diffuse and what impedes technically efficient innovations from catching on? Abrahamson makes suggestions for how organizational scientists can more comprehensively evaluate the spread of innovations. In later editions of Diffusion of Innovation, Rodgers changes his terminology of the 5 stages to knowledge, persuasion, decision, implementation, and confirmation. However, the descriptions of the categories have remained similar throughout the editions. Rate of adoption: the rate of adoption is defined as the relative speed at which participants adopt an innovation. Rate is usually measured by the length of time required for a certain percentage of the members of a social system to adopt an innovation. The rates of adoption for innovations are determined by an individual unregistered trademark S adopter category. In general, individuals who first adopt an innovation require a shorter adoption period when compared to late adopters. Within the adoption curve, at some point the innovation reaches critical mass. This is when the number of individual adopters ensures that the innovation is self-sustaining. Illustrating how an innovation reaches critical mass, adoption strategies, Rodgers outlines several strategies in order to help an innovation reach this stage, including when an innovation adopted by a highly respected individual within a social network and creating an instinctive desire for a specific innovation. Another strategies includes injecting an innovation into a group of individuals who would readily use said technology, as well as providing positive reactions and benefits for early adopters. Diffusion versus adoption. Adoption is an individual process detailing the series of stages one undergoes from first hearing about a product to finally adopting it. Diffusion signifies a group phenomena, which suggests how an innovation spreads. Adopter categories. Rodgers defines an adopter category as a classification of individuals within a social system on the basis of innovativeness. In the book Diffusion of Innovations, Rodgers suggests a total of 5 categories of adopters in order to standardize the usage of adopter categories in diffusion research. The adoption of an innovation follows an S-curve when plotted over a length of time. The categories of adopters are innovators, early adopters, early majority, late majority and laggards. In addition to the gatekeepers and opinion leaders who exist within a given community, change agents may come from outside the community. Change agents bring innovations to new communities IRST through the gatekeepers, then through the opinion leaders, and so on through the community. Rodgers unregistered trademark 5 factors. Rodgers defines several intrinsic characteristics of innovations that influence an individual unregistered trademark's decision to adopt or reject an innovation. Failed diffusion. Rodgers discussed a situation in Peru involving the implementation of boiling drinking water to improve health and wellness levels in the village of Los Molinos. The residents had no knowledge of the link between sanitation and illness. The campaign worked with the villagers to try to teach them to boil water, burn their garbage, install latrines and report cases of illness to local health agencies. In Los Molinos, a stigma was linked to boiled water as something that only the unwell consumed, and thus, the idea of healthy residents boiling water prior to consumption was frowned upon. The 2-year educational campaign was considered to be largely unsuccessful. This failure exemplified the importance of the roles of the communication channels that are involved in such a campaign for social change. Burt looked at the process of diffusion in El Salvador and asked whether a differential influence exercised by social integration on participation in the diffusion process was more significant than that exerted by other important diffusion-relevant variables. Heterophily and communication channels. Lazarsfeld and Merton first called attention to the principles of homophily and its opposite, heterophily. Using their definition, Rodgers defines homophily as the degree to which pairs of individuals who interact are similar in certain attributes, such as beliefs, education, social status, and the like. When given the choice, individuals usually choose to interact with someone similar to themselves. Homophilous individuals engage in more effective communication because their similarities lead to greater knowledge gain as well as attitude or behavior change. However, most participants in the diffusion of innovations are heterophilous, meaning they speak different languages, so to speak. The problem is that diffusion requires a certain degree of heterophily. If 2 individuals are identical, no diffusion occurs because no new information can be exchanged. Therefore, an ideal situation would involve 2 individuals who are homophilous in every way, except in knowledge of the innovation. The role of social systems. Opinion leaders. Not all individuals exert an equal amount of influence over others. In this sense, opinion leaders are influential in spreading either positive or negative information about an innovation. Rodgers relies on the ideas of Katz and Lazarsfeld and the 2-step flow theory in developing his ideas on the influence of opinion leaders. Opinion leaders have the most influence during the evaluation stage of the innovation decision process and on late adopters. In addition, opinion leaders typically have greater exposure to the mass media, more cosmopolitan, greater contact with changed agents, more social experience and exposure, higher socioeconomic status, and are more innovative than others. Research was done in the early 1950s at the University of Chicago attempting to assess the cost-effectiveness of broadcast advertising on the diffusion of new products and services. The findings were that opinion leadership tended to be organized into a hierarchy within a society, with each level in the hierarchy having most influence over other members in the same level, and on those in the next level below it. The lowest levels were generally larger in numbers and tend to coincide with various demographic attributes that might be targeted by mass advertising. However, it found that direct word of mouth and example were far more influential than broadcast messages, which were only effective if they reinforced the direct influences. This led to the conclusion that advertising was best targeted, if possible, on those next in line to adopt, and not on those not yet reached by the chain of influence. Other research relating the concept to public choice theory finds that the hierarchy of influence for innovations need not, and likely does not, coincide with hierarchies of official, political, or economic status. Elites are often not innovators, and innovations may have to be introduced by outsiders and propagated up a hierarchy to the top decision makers. Electronic communications social networks. Prior to the introduction of the Internet, it was argued that social networks had a crucial role in the diffusion of innovation, particularly tacit knowledge in the book The IRG Solution, a hierarchical incompetence and how to overcome it. The book argued that the widespread adoption of computer networks of individuals would lead to much better diffusion of innovations, with greater understanding of their possible shortcomings and the identification of needed innovations that would not have otherwise occurred. The Relevance Paradox. The social model proposed by Ryan and Gross is expanded by Valent, who uses social networks as a basis for adopter categorization instead of solely relying on the system-level analysis used by Ryan and Gross. Valent also looks at an individual's personal network, which is a different application than the organizational perspective espoused by many other scholars. Innovations are often adopted by organizations through two types of innovation decisions: collective innovation decisions and authority innovation decisions. The collective decision occurs when adoption is by consensus. The authority decision occurs by adoption among very few individuals with high positions of power within an organization. Unlike the optional innovation decision process, these decision processes only occur within an organization or hierarchical group. Within an organization, certain individuals are termed champions, who stand behind an innovation and break through opposition. The champion plays a very similar role as the champion used within the efficiency business model Six Sigma. The process contains 5 stages that are slightly similar to the innovation decision process that individuals undertake. These stages are: agenda setting, matching, redefining, restructuring, clarifying and routinizing. Domains. Policy. The theories of diffusion have spread beyond the original domain. In the case of political science and administration, policy diffusion focuses on how institutional innovations are adopted by other institutions, at the local, state or country level. An alternative term is policy transfer, where the focus is more on the agents of diffusion, such as in the work of Diane Stone. The first interests with regards to policy diffusion were focused in time variation or state lottery adoption, but more recently interest has shifted towards mechanisms or in channels of diffusion, where researchers find that regulatory agency creation is transmitted by country and sector channels. Technology. Perez, Moller and Mayer-Jahn suggested that diffusion is the process of the market penetration of new products and services that is driven by social nuances, which include all interdependencies among consumers that affect various market players with or without their explicit knowledge. Eveland evaluated diffusion from a phenomenological view, stating, OE technology is information, and exists only to the degree that people can put it into practice and use it to achieve value. Diffusion of existing technologies has been measured using S-curves. These technologies include radio, television, VCR, cable, flush toilet, clothes washer, refrigerator, home ownership, air conditioning, dishwasher, electrified households, telephone, cordless phone, cellular phone, per capita airline miles, personal computer and the Internet. This data can act as a predictor for future innovations. Diffusion curves for infrastructure reveal contrasts in the diffusion process of personal technologies versus infrastructure. Consequences of adoption. Both positive and negative outcomes are possible when an individual or organization chooses to adopt a particular innovation. Rodgers states that this area needs further research because of the biased positive attitude that is associated with innovation. Rodgers lists three categories for consequences: desirable versus undesirable, direct versus indirect, and anticipated versus unanticipated. In contrast, Wedgett details two categories: public versus private and benefits versus costs. Public versus private. Public consequences comprise the impact of an innovation on those other than the actor, while private consequences refer to the impact on the actor. Public consequences usually involve collective actors, such as countries, states, organizations or social movements. The results are usually concerned with issues of societal well-being. Private consequences usually involve individuals or small collective entities, such as a community. The innovations are usually concerned with the improvement of quality of life or the reform of organizational or social structures. Benefits versus costs. The benefits of an innovation obviously are the positive consequences, while the costs are the negative. Costs may be monetary or non-monetary, direct or indirect. Direct costs are usually related to financial uncertainty and the economic state of the actor. Indirect costs are more difficult to identify. An example would be the need to buy a new kind of pesticide to use innovative seeds. Indirect costs may also be social, such as social conflict caused by innovation. Marketers are particularly interested in the diffusion process as it determines the success or failure of a new product. It is quite important for a marketer to understand the diffusion process so as to ensure proper management of the spread of a new product or service. Mathematical treatment. The diffusion of an innovation typically follows an S-shaped curve which often resembles a logistic function. Mathematical programming models such as the SD model apply the diffusion of innovations theory to real data problems. Complex systems models. Complex network models can also be used to investigate the spread of innovations among individuals connected to each other by a network of peer-to-peer influences, such as in a physical community or neighborhood. Such models represent a system of individuals as nodes in a network. The interactions that link these individuals are represented by the edges of the network and can be based on the probability or strength of social connections. In the dynamics of such models, each node is assigned a current state, indicating whether or not the individual has adopted the innovation, and model equations describe the evolution of these states over time. In threshold models, the uptake of technologies is determined by the balance of two factors: the usefulness of the innovation to the individual as well as barriers to adoption, such as cost. The multiple parameters that influence decisions to adopt, both individual and socially motivated, can be represented by such models. Computer models have been developed to investigate the balance between the social aspects of diffusion and perceived intrinsic benefit to the individuals. When the effect of each individual node was analyzed along with its influence over the entire network, the expected level of adoption was seen to depend on the number of initial adopters and the network's structure and properties. Two factors emerged as important to successful spread of the innovation: the number of connections of nodes with their neighbors and the presence of a high degree of common connections in the network. Using the logistic function, researchers were able to provide new insight into market penetration, saturation and forecasting the diffusion of various innovations, infrastructures and energy source substitutions, congruity of waves. Criticism. Much of the evidence for the diffusion of innovations gathered by Rodgers comes from agricultural methods and medical practice. Various computer models have been developed in order to simulate diffusion. Beneris developed a systems dynamics computer model that considers various diffusion patterns modeled via differential equations. A number of criticisms imply limits to its usefulness for managers. First, technologies are not static. Continual innovation attracts new adopters all along the S-curve. The S-curve does not just happen. Instead, the S-curve may be made up of a series of bell curves at different sections of a population adopting different versions of a generic innovation. Rodgers placed the contributions and criticisms of diffusion research into four categories: pro-innovation bias, individual blame bias, recall problem, and issues of equality. One of the cons of the approach is that the communication process involved is a one-way information flow. The message sender has a goal to persuade the receiver, and there is little to no reverse flow. The person implementing the change controls the direction and outcome of the campaign. In some cases, this is the best approach, but other cases require a more participatory approach. See also. References: Diane Stone, A Euro Transfer Agents and Global Networks in the A Euro Transnationalization, A Euro Unregistered Trademark of Policy, A Euro Unregistered Trademark, Journal of European Public Policy, 11, 3, 2004, 545, A Euro 66. Diane Stone, A Euro Non-Governmental Policy Transfer, The Strategies of Independent Policy Institutes, A Euro Unregistered Trademark, Governance, An International Journal of Policy and Administration, 13 2000, 45, A Euro 70. Diane Stone, A Euro Learning Lessons and Transferring Policy Across Time, Space and Disciplines, A Euro Unregistered Trademark, Politics, 1999, 51, A Euro 59. David L. Loudon and Albert J. Della Bitta, Consumer Behavior, 1993. Rodgers, Everett M. Diffusion of Innovations. Glencoe, Free Press. ISBN A0-612-62843-4. Rodgers, Everett M. Diffusion of Innovations. New York, Free Press. ISBN A978-0-02-926650-2. Wedgett, Barbara. Integrating Models of Diffusion of Innovations, A Conceptual Framework. Annual Review of Sociology 28, 297, A Euro 306 doi, 10.1146/Annuary Soc. 28.110,601.141,051. JSTORA 3069244, Notes. External links: The Diffusion Simulation Game, about adopting an innovation in education. The Pencil Metaphor on Diffusion of Innovation, particularly ICT in Education. Diffusion of Innovations, by John Rowland, summarizing ideas in the field. Diffusion of Innovations, Strategy and Innovations. The DSI Framework by Francisco Rodriguez Gomez, academia.edu. Share Research.